We live yet? Are we live? Are we live yet? All right, we're live. All right, what's up, guys? Mike the Coder here, and today we're going to do a ad hoc grind. All right, so the reason why I'm stuck in gray, and it's not because I'm bad at certain data structures, but ad hoc problems are not a thing on lead code. It's not really like a thing on lead code. And these are the problems that involve games, and I'm really bad at them. So, because people keep making fun of me saying, oh, you're a newbie, blah, blah, blah. Well, I'm going to get good at ad hoc, and then I'll just get to green or jump to cyan, okay? So, yeah, I'm going to just try. We're going to do an ad hoc grind today. So, I have a list of ad hoc problems that I found on Codeforces that are rated 1200. So, I should be able to solve these if I think extremely difficult. So, extremely hard. I have been doing I did at least 14 already, I believe. Yeah, I've done at least 14 already without looking at the solution, which is pretty good. But I need to do a little bit more. And these ad hoc problems are just like so annoying because I really don't know what to do sometimes. All right, so let's do this problem. Okay, all right, so Bob and Alice are playing a game on an array of n numbers. Alice and Bob make a move with Alice going first. Okay, so in her turn, the player makes the following move. If the first value is 0, the player loses the game. Otherwise, we're going to pick some random index starting from 2 to the n. And then the player decreases the value A1 by 1 and then swaps it with the current index. Determine the winner of the game if both players play optimally. Okay, so, all right. So for these, personally, I think the only way to do this is to come up with an example because there is like no way in hell I would know what to do just by looking at this. I'm going to guess that if you want to, what does it say? A1 to go to 0, player loses the game. So if we're swapping A1 with if we decrease the value A1 by 1 and then we swap A1 with any value in the array, then if we keep decreasing the value by 1, either so determine the winner of the game, both players play optimally. Okay, so if Alice wants to win, she should, who goes first though? Alice goes first. Okay, she should go find the smallest value and decrease it by 1 and then swap it with the first value, right? On her turn, she should find the smallest value and decrease it by 1 and swap it, because that way Bob would be screwed, because then he would have to, Bob would be screwed, because then if he, so let's say we had like, I don't fucking know. Like, let's say we have 1, 2, 3, 4, 5. So it's Alice's turn, right? So Alice finds the number from the second index to the end, right? So if she finds the number 2 and decreases it by 1, so 2 minus 1 becomes 1, and then we swap it with the first value of 1, so then we would have 1, 1, because it's still the same 1, 1. Then Alice goes first, right? Then the player makes the following move. Okay, so then okay. So then Bob would do is, I think Bob would, it would be more optimal for Bob to grab the smallest number also, right? Because if he grabs the smallest number 1 and minuses 1, right, this would give you 0. And if you swap it with Alice, we have 0, what is it, 0, 1? 0, 1, right? And then I think who wins? Wait, who loses? I think Alice would lose. Wait, yeah. Then Alice would lose. Okay, so for us, if you want to brute force, I think the most efficient way would be to keep finding the smallest number, right? Decrease it by 1 and swap it with the the first value in the array. And if any of the values reaches 0, then Alice wins. Otherwise, Bob wins, right? So let's see. If A1 reaches 0, the player loses the game. Oh, wait. Wait, which player loses the game? Says Alice goes first. Does that mean like, okay, so my main question is like, if Alice goes first and then Bob goes second, right? Bob goes second, then who wins here? Because is it Alice's turn does Alice lose because she hits on her turn it's 0, or does Bob lose because on his turn it hits 0? So like who would win and lose in this situation? So let's look at the examples because I don't know what they mean. Maybe I should post like the question into the chat or something. I don't see anyone commenting in the chat. Yep, I'm just talking to myself. Whoop-de-doo. All right. Let's just copy this, put it in the chat, current problem. So I put it in the chat, and then I'm just going to, hey Omega, hello. I'm going to pin this. This is the problem. This is the current problem I'm doing. Okay, so Alice moves the first value. Okay, so I wonder who in the first case. Okay, so let's look at 1 1. So in the first case, Alice can choose 2. -1 becomes 1. Okay. Wait, what minus is 1? Yeah, okay. Oh, the player decreases the value A1 by 1 and then swaps it. Oh. Okay, so that's different. I read the problem wrong. Okay, so that would be different. So because if it's, you said 1 1, because we have 1 1. If we decrease this problem -1, we get 0, right? And then we have 1 here, and then you swap 0 with 1. Wait, hold up. Decreases the value A1 by 1, and then swaps A1 with AI. So we decrease this by 1, so we get 0, and then we swap 0 with 1. So then this would become 1 0, right? Then Bob chooses 0, decreases value by 1, swaps it, so then we get 0 0. So on Bob's turn it reaches 0, right? So who wins? Wait. As A1 equals 0. Oh, so whoever's turn A1 equals 0, then the other person wins, right? Because okay, so whoever person's A1 reaches 0, you lose. So if okay. Right, so your best bet is to find the smallest number, decrease A1 by 1, and then swap it with the smallest number, I think. That would be the fastest way. So I think that'll get TLE. I think I did this problem before, but I couldn't figure out, and I don't remember what I wrote for my own solution. So we'll rewrite our own solution on the brute force solution, and then we'll see if we could find a pattern on why Alice or Bob wins on this dumb pattern thing. See, these problems are really dumb because like you don't really know, like it's pretty hard to determine how to do some of these problems. You have to think so much. And it's not like something that I normally do. Like I don't have to do so much thinking on lead code problems. All right, let's look at the chat. Print hello world. Hello world. Printing hello world. All right, I'll put the chat up as a pop out. Okay? Put the chat out as a pop out. But yeah, let's do this. Okay, so Alice and Bob. Bada bada bing bada boom. This is really taking a long time for Visual Studio to load. Maybe I should put on VS Code. I'm gonna set up on my other Linux laptop for maybe this laptop can't handle. Does Linux work on I feel like Windows laptops get slower over time. Maybe it's just me. Also, my laptop is like really bad right now. Like it can't handle that much stuff. Oh no, I have a gaming PC this whole time. I use it for computer graphics, but I never like use it for programming. I should actually I need to buy like a. So I have a mouse. I have that stuff. I need to buy like, what do you call it? Yeah, I need to buy like I need to buy a monitor. That's what I need to buy. Because I don't have a monitor. If I could set up like my own PC here, this would be cool streaming. Right now I'm using my laptop, so. Yeah. So you're right, Omega. You want the opposite player to get A1 equal to 1. So I haven't been thinking about like an optimal solution right now, but what I'm thinking of is like finding the smallest number, decreasing it by 1, like decreasing A1 by 1 and then swapping it. So that's my current algorithm. Right? Because if the other person reaches if the other person reaches 1, then or 0 actually. Yeah. If the other person reaches Yeah, okay. So if A1 equals 0 and it's Alice's turn, then Alice lose. So we'll come up with a brute force solution. Then figure this out. Why are you just not responding? Like, this is so annoying. Okay, I'm gonna like, maybe it's like just like the amount of processing power that my computer is dealing with. Another thing, I could just code on like an online compiler if Visual Studio keeps not loading. It was working like earlier today. Maybe it's like all the OBS and all the stuff in the background and all this other stuff. I don't think it's paint though. It can't be paint. It can't be a paint problem in paint. All right, if it still doesn't work, I'm using an online compiler. But yeah. What we're gonna do is like, we're gonna try to do like, I want to do some graphics programming in C++. I feel like this channel should become like a C++ channel, you know, for development. Like, I don't just want to do competitive programming. Like, it's cool to do competitive programming all the time, but there's only like a small number of people that does competitive programming. I mean, it's cool though. Like I could do like a lot of the problems, but oh yeah, this was an XOR problem that I was doing. All right. Okay, so let's see. Read up. Okay, so we need Boolean on Alice's turn. So all right, so we're gonna have a Boolean Alice's turn. So Alice's turn will be true, right? That's our Boolean. And let's see. Okay, yeah. Okay, so what is the test case? Okay, so we read in n and read in the size n. Okay, so that's not hard. Okay. I don't know why this opened up like 2 more Visual Studios. Windows laptops are just like so like slow. Man, I'm getting a rant on Windows. All right. Vector. It is typing so slow also. Man, this live stream is like really slow. Oh, nope. It's going back now. Okay. So I'm going to read in the array. Okay. What should we do first? What is AI first? AI is 1. Okay, so we're going to do while r at 0 is not equal to 0, right? And then what we're going to do is we're going to yeah, okay. So Alice's turn right now. So we're going to loop from I is 1, I is smaller than n, I plus plus. We're going to find the smallest number. So smallest number, we'll set it to long line max first, and then we need to find the index. So if r at I is greater than smallest number, we're going to set smallest index to equal I, right? And then we're going to set it's smaller, less than or equal to smallest number. And we're going to set smallest num is going to equal to r of I. Okay? So this will find the smallest number that we have throughout the array. And then what we're going to do is we're going to swap it with, so on Alice's turn, r at 0 is going to decrease by 1, right? And then we're going to swap it with the smallest number. Okay? So we're going to swap r at I with the r at 0 with r at small index. Okay, so that'll swap them both, and then we're gonna set Alice equal to not Alice. So if it's Alice's turn and RIU is equal to 0, so if it's Alice's turn, then that means that an RI reaches 0. So at the end of this while loop, that means Bob wins. Otherwise, Alice wins. See out, Alice wins. And ideally, this should work because this should be a brute force solution. So we should be able to get the other scenarios out. So we should get a TLE, but this should work on the other inputs. All right, we got a wrong answer. What is the problem? Bob, Alice, Bob. Why is the last one? Suspected Alice, but found Bob. Three, 5, 4, 4. So we have 3, 5, 4, 4. So we have 5, 4, 4. Could use notebook. Oh yeah, Jupyter notebook or maybe. 3, 5, 4, 4. Let's see. So why is this not working? Let's see. I wonder why it's not working though. So let's see. So let's go back to the problem, reread it again. Player chooses some number. A1 equals 0. Player loses the game. Otherwise, player chooses an index 2 for the n. Then decrease the value A1 by 1. It swaps A1 with AI. Yeah. So okay. So this is not. What are we doing wrong? Okay. So let's say 5, 4, 4. Alice's turn. He minuses A1 by 1, so it becomes 4. And then we swap with the smallest number. Smallest number is 4, so it becomes itself. Bob's turn. Bob decreases value by 1 by 3. Swaps to the smallest number, 4. So then we get 4, 3 because 4 gets swapped with 3. Alice's turn decreases the number by 4 by 1, so we become 3. Swap with the smallest number, 3, 3. Same thing. Bob's turn finds the smallest number, decreases by 2, 2. Swap it with the smallest number, we get 3, 2. Right? Alice's turn minuses by 1 by 2, so 2. Swaps with the smallest number, 2, 2. So it's still 2, 2. Alice's turn, or I would say Alice. Bob's turn now, -1. Swap 1, so it becomes 2, 1. Alice's turn, -1 was 1. Swap with the smallest one, 1, 1. Okay. Bob's turn, -1, 0. Swap with 1, 1, 0. So now I have 1, 0. So this becomes 1, 0. Alice's turn, -1, 0. Okay, so then Bob wins. In our situation, Bob would win. Okay, but really it's Alice that wins. What about third case? What is Alice's winning strategy then? Should we pick the largest number? That just like delays everything though. We want this to go to 1, right? The opponent to go 1. Wouldn't it make more sense to get the smallest number? That's like stupid. Because if you get the largest number, you're basically stalling in this game. Solve it when all numbers are smaller than or equal to 3. Okay, we could try that. So we have 2, 2, 2. Okay, so let's say Alice's turn. So it's Alice. -1, get 0. Not 1, 0. Because 1, swap it with 2. So this becomes 2, 2, 1. Bob's turn. -2 becomes 1. Swap it with 1. 1, 1. Alice's turn. -1 becomes 0. Swap it with Bob. This becomes 1, 0. Bob's turn. -1 becomes 0. Swap it with 0, 0, 0. Bob loses. Alice wins. Can Alice win in this case? You know, let's see if we could find the. Let's see if the largest one works. This is just to see if like. Let's see if this would work. Ideally, we should try to get a TLE first. Nope. It's not the smallest or the largest. What is it then? How do you get Alice to win for the third one? Like, what is the optimal scenario for this? Like 5, 4, 4. Alice turns. Remember, we decrease A1 by 1. Yeah, so we decrease this by 1, so we get 4. We swap it with 4, we get 4, 4. Bob's turn. What should he do? This decreases by 1 to 3. She swaps with the largest one. Swap it with 4. Well, they're both 4, so swap it with 4, so this becomes 4, 3. Alice's turn. It's at 4. Oh, maybe you should swap it with the 4 in this case. So -4 becomes 3. Swap it with 4, so we get 4, 3. So Bob's turns. -1 becomes 3. Swap it with 3. We get 3, 3. Alice's turn. -1 becomes 2. Swap it with 3. Become 3, 2. Right. Bob's turn. -1 becomes 2. Swap it with 3. So should we try to make them all equal? So we get 2, 3. Alice's turn. -1 becomes 2. Swap with 2, 2, 2. Bob's turn. -1, 1. Swap it with 2, so we 2, 1. Now we have Alice's turn. -1, 1. Swap it with 1, 1, 1. Bob's turn. -1 becomes 0. Swap it with 1. We get 1, 0. Alice's turn. -1. We get 0. Swap it with 0, 0, 0. So Alice loses, Bob wins. But Alice wins on this last one, right? I do not have a Discord. Hey, Sid. From TikTok. Cool. We're doing a hard algorithm problem. These are dumb games, stupid games that I can't solve because they're not normal. These are not normal games. Competitive programming, so hard. I do not have a Discord. Competitive programming is too hard for me to get into, so I was just playing around with Pi game tutorials. Yeah, you could do that. Competitive programming is very hard. If you're from TikTok, this is competitive programming. We're doing competitive programming problems. So this is like, these are like games. These are like a lot of thinking. So if you're new here, basically we have a game where Alice and Bob plays a game, and what we're trying to do is like we're trying to get we decrease, we're given an array of numbers, and Alice starts, and we decrease the first value by 1, and then we swap it with any other number in the list besides this one. And then if this number becomes 0 on any of the guys' turns, then they lose. Okay, so we're trying to find the most optimal way for 5-4-4. So I'm trying to think what you can do here. Okay, so we decrease 5, we get 4. We swap 4, 4. So that's Alice. Okay, so let me just make this really small because like this is really hard. So 5 minus 1 becomes 4. 4 swaps 4. We get 4, 4. Bob's turn, minus 1. 4 minus 1 is 3. Swap it with 4. So we get 4, 3. 4. Alice's turn, minus 1 becomes 3. Swap it with, what should she swap it with? Should she swap it with 4 or should swap it with? I think she should swap with 3. Swap with 3, we get 3, 3. Bob's turn, minus 1. 3 minus 1 becomes 2. I think he should swap it with 3, so we get 3, 2, 4. Alice's turn, 3 minus 1 becomes 2. Swap it with, I think you should swap with 2, so then we get 2, 2, 4. Bob's turn, 2 minus 1 becomes 1. Swap it with 2, so we get 2, 1, 4. Alice's turn, 2 minus 1 becomes 1. Swap it with 1, so we get 1, 1, 4. Bob's turn, Bob minuses 1 from here becomes 0. Swap it with 1, we get 1, 0, 4. Alice's turn, minus 1 becomes 0. Swap it with 0, get 0, 0, 4. And then we lose because we reached 0. So Alice lost. So Bob wins. But how do we get Alice to win? That's the problem. Where should she swap? This is a tough one. This is a tough problem. We want Alice to win. So how are we going to get Alice to win? Okay. Let's say that Alice did not swap at this time with 2. So it was 1, 1, 4. If she minuses 2 become 1 and swap it with 1, we get 1, 1, 4. If he minuses become 1 becomes 0, swap it with 1, 0, 4. If she minuses 1 from 1, swap it with 0, 0, 0, 4. You fail. So we want the other person to reach 1 first. So let's say at this point, we don't swap with 1, but we swap with 4. So let's say... So on Alice's turn, instead of -2, we're going to minus... Oh yeah, well, -2 become 1. We're going to swap with 4. So we get 4, 1, 1. Let's say Bob's turn. We -4 bit 3. Swap it with 1. So we get 1, 3, 1. Alice's turn, -1 becomes 0. Swap it with 3. You get 3. Oh, no, swap it with... Swap it with 3. So we get 3, 1. Alice -1 becomes 0. Should we swap it with 1? So we get it 1, 3, 0. Bob's turn, -1 on... Alright, so let's go back to the top. Bob's turn, -1 becomes 0. Swap it with 0. We would get 0, 3, 0. And then I think Bob loses. No, wait. Whose turn is it? Is it Alice's or Bob's? Wait. If it reaches 0 on someone's turn, they go... Oh, wait. Alice can only choose I equal to 2, which we get 1, 0. Then Bob, in his turn, he chooses I equal to 2, which makes the right E equals 0, 0. After the turn, it's Alice's turn, though. So here, it's Alice's turn. It's 0, 0, so Alice loses and Bob wins. Huh. So how would Alice win here? All right, let's say Alice decreases, like, tries to get them all equal. So 3, 3, 3, 3, 4. So -4 becomes 1, 3. We swap it with 4, so we get 4, 3, 3. Bob's turn, -4 becomes 3. Swap with 3, we get 3, 3, 3. I don't know what that noise was. Sounded like a motorcycle or something. Alice's turn, -3 become 2. Swap it with 3, so we get 3, 2, 3. Bob's turn, 3 -2. 3 -1 becomes 2. Swap it with... Let's make them all 2. So swap it with 3, so we get 3, 2, 2. Alice's turn, 3 -1 becomes 2. Swap with 2, so we become 2, 2, 2. Bob's turn, it's 2, 2, 2. 2 -1 becomes 1. Swap it with one of these, so then we get 2, 1, 2. Alice's turn, -2 -1 is 1. Swap it with 2, so we get 2, 1, 1. Bob's turn, 2 -1 gives 1. Swap it with one of these, so then we get 1, 1, 1. Alice's turn, -1 becomes 0. Swap with these, become 1, 0, 1. Bob's turn, -1 goes 0. Swap it with 1, so we get 1, 0, 0. Alice's turn, 0, 0. Bob's... It's Bob's turn now. Now it's 0, 0, 0. So yeah, I think Bob loses. So would it make more sense to make them all the same number? Is that how you would do it? After 2-1-2, choose 1. So the next turn you give the opposite player 0. Two, 1-2. Yeah, see, I was thinking about picking the smallest one, but that didn't seem right. Like, when I submitted that was not right. Like, if I picked... So, 2-1-2, right? I picked this one, right? I swap... Wait, what did you say? 2-1... Choose one. Yeah, so... Okay, so I -2 becomes 1. Swap with 1. We get 1-1-2. Here, -1 swap with 1. You get 1-0-2. -1 swap with a 0. You would get 0-0-0-2. And then it hits his turn. And then... It's Bob's turn. Bob loses. So isn't it just subtracting 1 and then getting the smallest number? And then if they're all the same... Aren't you always just getting the smallest number? Like, I don't get why... Okay. Let's go back to why... How does Alice win? I just don't get it. Okay. 5 minus 1 goes 4. Swap it with 4, so 4, 4, 4. Bob's -1, 3. Swap it with 4, 4, 3, 4. Alice's turn, -1, get 3. Swap it with 3, 3, 3, 4. Bob's turn, -1, gets 2. Swap it with 3, gets 3, 2, 4. Alice's turn, -1, becomes 2. Swap it with 2, 2, 2, 4. Bob's turn, -1 becomes 1. Swap it with 2, so 2, 1, 4. Alice's turn, -1 goes 1. Swap it with 1, 1, 1, 4. Bob's turn, -1, 0. Swap it with 1, 1, 0, 4. Alice's turn, -1, 0. Swap with 0, 0, 0, 4. Bob's turn, now 0, so Bob loses. Alice wins. So why aren't you getting this? Why isn't the smallest one working? What was the... Our goal is to get TLE, actually. I picked the largest number. I picked the smallest number. Shouldn't it be one of those? I mean... Okay, let's copy our code and then actually run through it. Why it's not working properly. Five, 4, 4. What? Hmm. Bob loses. Swaps 1. Bob loses. When the game loses, the game loses after the turn. Then the game, if the I think it's the other player's turn that happens, and then the whichever turn it hits 0, then that player loses. That's what I think from reading this, because in this case, right, Bob on his turn chose AI equal to 2, right? So this -1 becomes 0. Swap it with this one, and then 1, 0. Alice -1. Swap it with 0. You get 0, 0. Wait. Okay, so something doesn't make me. Okay, I'm not understanding the rules of this game completely. It's 1, 1, 1. Okay, Alice -1 gets 0. Swap it to 1, 0, 1. Well, 1, 0. Bob's turn -1 becomes 0. Swap with 0, 0, 0. Alice's turn, it hits 0, 0. So Alice loses. Right? Because on her turn, it hits 0. Bob's last turn was 0, 0. But since that was on his turn, he didn't lose. Right? On Alice's turn, it hits 0. So that's why Alice loses. And then Bob wins. So, the game doesn't end. Otherwise, Bob would have. Otherwise, Bob loses right here. Wait, let's see. Yeah, otherwise, Alice would win here. Because if Bob reaches 0, then Alice wins. Right? But Bob wins. It's because on Alice's turn, it hits 0. It's not like an after a turn. So I think I understand the problem correctly. Like the next turn, if it reaches 0, right? Then if it's Alice's turn, Bob wins. If it's Bob's turn, Alice wins. So I think this is right. But I'm not really understanding why I'm wrong, though. Why the third problem, how Alice could win. Unless we want everything to reach the same number. Like, if we're trying to get everyone to reach the smallest number, that would be the other thing, but... What is this heart? Oh, it's an emoji thing. Because we want Alice to win. If we want Alice to win, we need to think about, like, how does Alice win on 544? That's what I'm trying to understand. Like, how does Alice win on 544? I already spent a long time on this problem, but it's already 12 a.m. Jesus Christ. We could spend another hour, then I'm going to take a shower, go to bed. So we have 544. How does Alice win? 5 minus 1, 4, 4, 4, 4, right? Then what is Bob's turn? Minus 1, 3. Swap it with 4, 4, 3, 4. Alice's turn. Minus 1, 3. Swap. Let's swap it with 3. Okay, so then we swap with 3. It's 3, 3, 4. Bob's turn. Minus 1, 2. Swap it with 3. 3, 2, 4. Alice's turn. Minus 1. Swap it with 2. 2, 2, 4. Bob's turn. Minus 1, 1. Swap it with 2, 2, 1, 4. Alice's turn. Minus 1. Swap with 1, 1, 1, 4. Bob's turn. Minus 1 becomes 0. Swap it with 1 goes 1, 0, 4. Alice's turn. Minus 1. Swap it with 0, 0, 0, 4. Bob's turn. Hits 0, so Alice wins. Yeah. So, according to our algorithm, we should be getting the smallest number, and it should get... Alice should hit 0, 0, 4. It ends 0, 0, 4, right? And then we set Alice is not equal to Alice, so let's look at the thing here. Minus 1, yeah. You find the smallest, swap it. So we should hit Bob's turn. He hits a 0, so Alice should win. Oh, no, wait. Alice's turn minus 1, 1, 0, 0, 0, 4. Alice hits a 0 here. So Bob wins? Wait. Oh, okay. At this situation, if this reaches 1, don't swap it with 0. So Alice should not swap it with 0. So if she wants to win, oh fuck. Alice swaps it with minus 1 gets 0, swap it with 4. So we get 4, 0, 0. Bob's turn, minus 1, 3, swap it with 0, gets 0, 3, 0. Hits Bob. So Alice's turn. Alice gets 0. No, wait. I don't understand. I don't understand. I don't really understand what's going on. I mean, the only way to get better at math problems is to do more math problems. This isn't even math. This is like games. This is game theory. Like, is this solving a math equation? No. Like, this is just like, who's gonna win if you solve optimally? Go. Okay, it's probably really getting on my nerves. Okay, let's just see like why 1, 3, 5, 4, 4. What each of the numbers are giving us. All right, right now it's 4, 4, 4. Is that what we had in our picture? Yeah. All right. Let's see if I can hit continue. 3, 4, 4. Oh, how's it 3, 4, 4? Minus 1. Swap it with the smallest number. 4, 3, 4. Oh, 3, 3, 4. It should be 3, 3, 4. What is it? What is mine giving me? Oh, yeah. It didn't swap. 4, 4, 3. Okay. 4, 4, 3. Am I doing the smallest one? Am I doing the smallest one? What am I doing? 4, 4, 3. Wait. 3, 3, 4, 3. Minus 1, 2. Swap it with 3. Should you get 3, 4, 2? 3, 4, 2. Minus 1, 2. Swap 3, 4, 2. Swap with 3. 2, 2. So what happens here? 2, 4, 2. Minus 1 gives 1. Swap with 2. Should we get 2, 4, 1? Right? After the next one. Yeah, 2, 4, 1. Minus 2 gets 1. Swap it with 1. Get 0. Swap with 1. So you get 1, 1, 1, 4, 1. Whose turn is it? It's... I don't know whose turn it is. Okay. Swap it. 0, 4th 0. Yeah. What is Alice? Alice is false. It's Bob's turn. Bob hits a 0. Therefore, Alice wins. Yeah. That's right. I got it right. Wait. Oh, wait. Am I not resetting the Boolean? That might be why. Oh, I'm not resetting the Boolean. I need to do that after every test case. Okay. So, I think the smallest should win. Picking the smallest number makes sense. Our goal is to get TLE. Because if we get TLE, we could try to optimize it. Bob Alice House. Yes. Okay, so my code was working properly. I was not resetting the Boolean. Jesus Christ. Okay, so it makes sense to pick the smallest one all the time. Okay, we got TLE. Okay, so that's good. Okay, so that means our code worked in the previous value ones. So the idea of picking the smallest number and then minusing it and swapping it makes logically sense. Okay, now we could so now we have to figure out a faster way to do this. Okay, so -1, swap it, -1, swap it, -1, swap it, -1, swap it, -1, swap it. Smallest number, -1, swap it, -1, swap it, -1, swap it. Okay. All right. So, what we could do is instead of minusing 1, we could just subtract the whole number. So if we had like, so we have 5, 4, 4, right? And Alice's turn. But the problem is we don't know what turn to do. Right? Because if I find -1, okay, so let's write out the values right. So if I have 5 -1, 4, 4, swap 4, 4, 4. 4 -1, 3, swap 4, 4, 3, 4. Alice's turn, -1, 3, swap 3, 3, 4. Bob's turn, -1, 2, swap 3, 3, 2, 4. Alice's turn, -3, -2, swap 2, 2, 2, 4. Bob's turn, -2, 1, swap 2, 2, 1, 4. Alice's turn, -1, 1, swap 1, 1, 1, 4. Bob's turn, -1, 0, swap 1, 1, 0, 4. Alice's turn, -1, 0, swap 0, 0, 0, 4. Bob's turn, now it's 0, 0, 4. It's 0, 0. Bob loses. Alice wins. Okay. So let's see. What were the numbers? 4, 4, 4, 4, 3, 4, 4, 3, 3, 4, 3, 4, 4. In the end, we had 1, 0, 4, right? Or 0. Okay. 1, 0, 4. So we can find the smallest number 4 minus 4 on both sides. So then we get 1, 0, 4. And then that'll be Bob's turn. So that would skip a bunch of this stuff. How many values did Alice do? So he did 1, 2, 3, 4, right? Subtracting and swapping. So if it's Alice's turn, and if we just find the smallest and subtract by it, we get 104. And then we could just it'll be Bob's turn, right? And then it'll be 104. And then we could do the same thing, minus 1. Swap it. Wait, let me think. How would you do this? $104. Find the smallest number, right? Subtract it. 0, 0, 0. Oh, you get 104. Oh, crap. Okay. If Bob's turn reaches 1, Bob loses. Right? So yeah, so this time we're going to check if instead of checking if it reaches 0, we're going to check if it reaches 1. We're going to find the smallest number and subtract it from the value, and then setting that value to be 0. And then if it reaches so each turn, so Alice's turn, we're going to skip all this computation. We find the smallest number, 4, subtract it, 104. Now it's Bob's turn. Bob's turn is 1. Bob loses. Right? Bob just automatically loses. So Alice wins. I think that makes sense. Logically, that makes sense. So we could try that. So we could do. Okay. Okay. So we're not gonna subtract this. We find the smallest number, and then we're gonna set R at the smallest index be equal to 0. Oh no, R at 0 minus equal to R at smallest index. Right? We're not going to swap. And then we're going to set R at smallest index. So the one at the smallest index, we're going to set that to 0. Okay? Alice's turn so now it's going to be Bob's turn. When this is not equal to 1. Okay. So if it's Alice's turn and it reaches 1, so let's look at this. If it was Bob's turn, it reaches 1, Alice wins. Alice wins, yeah. So if it's Alice's turn, it reaches 1, Bob wins. If it's Bob's turn, it reaches 1, Alice wins. Okay, so I think this should work. This should make it way faster. It's going to fail at test 0. Timeline on test 0 What? Huh? What? Timeline exceeded. One two two one new. Oh, we hit less than 0. Okay. Okay, let's do less than or equal to 1. Because then, in the case when it's 1, 1. Okay, yeah. In the weird case when it's 1, 1, then it's a weird thing. What the fuck is going on with Visual Studio? Hmm. Come on. Why is it TLEing? Let's look at it. Why are you TLEing? Okay. Smallest number is 1. We know this. Oh, it hits 0, 0. Okay. Oh, what the hell? Why did I say less? If it's greater than or equal to 1, then we stop. You are so slow. Why? We hit 0. Fuck. We hit 0. Oh, wait. Bob wins, right? Is it right? Bob wins? Wait, let me check. Bob spoke. Why did Alice win? Bob wins. Okay, if we hit 0. Okay, this is so annoying. Like, I. Okay, you know what? Fuck it. For this weird circumstance, if R0 is equal to 0 and as Alice's turn, let's just say Alice wins. I really don't want to care about this that much. Of course, this probably is not the right way. I don't think you could, like, corner case your way through this. My guy. Whoever reaches 1 to 0 should win. Ugh. ABC contest. I could try it. Oh wait, no. Yeah, I could try. I could try ABC contest tomorrow. What time is it? Is that 7 or 8? If it is, then I'm gonna leave at like 1 then, because I do not want to. I don't know. -1, 1, 0. 0, 0. Okay. If it's Bob's turn and we reach 1, 0, 0, 4, Alice wins. Right? Alice wins. Okay, so but what is it? What if it was 1, 1? So if Alice -1, so I want 1, 0. Bob's turn -1, 0, so 0, 0. Alice's turn is 0. Bob wins. Alice's turn 0, 0. Yeah, wait. Alice's turn is 0, 0. So Bob wins. So after this, Alice's turn should be 0, 0. So if it's Alice's turn, Bob wins. So if why did I get Alice wins in the? Why? I don't understand. Wait, what am I doing wrong? If it's Alice's turn, Bob wins. What? Alice's turn, Bob wins. It reaches 0. Oh, wait. What? 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 I don't understand. Why? Okay, so 1, 1. Okay, this is so dumb. Okay. Alice's turn. It's 0, 0. Right? It's not Alice's turn anymore. It's Bob's turn. But we hit 0, 0. So in this situation, we hit 0-0. Bob's turn hit 0-0. Bob's turn hit 0-0. Alice wins. Okay, yeah. What the fuck? Okay. Oh. Oh. I might attempt ABC today. I'll register for it, but if it's super early, I would have to think about it. I could Oh shit, no, it's Oh yeah. Oh, it's at 7. Fuck. That means I have to wake up. All right, yeah, all right guys. I'm going to do this contest tomorrow and it's at 7 a.m. So for that, I'm gonna have to end the live stream. We're gonna try to solve this problem later. But I'll keep thinking about this problem. Yeah, I'll do this ad coder problem. This ad coder contest. Right now, employee. Let's say Lin, Michael Lin, email address, employee, University of California, Berkeley. Major department, computer science. I think it's robotics, but mechanical engineering. Graduation was yes, sure. All right, I'm going to attempt this contest tomorrow. I'll record myself in a screencast and we'll see if I can solve this problem tomorrow. But anyway, we'll try to solve this problem for swap game. I feel like we should be able to. I think I understand, like, you have to find the smallest one and maybe you have to mod by 2. Maybe that would be easier. Because then you would be, right? This problem's so hard. Anyway, check you guys later. Peace. This problem is really hard. These are the reason why I really hate these games. Because games are like really hard to improve on. Like if you're doing competitive programming and you need to try to figure out how to do games, it is really hard. Oh, thanks. Yeah, I'm gonna do another C++ tutorial course classes. We're gonna try to, do modern C++, and I'll try to do like more C++ stuff. But yeah, I'll stick a little away from the competitive programming. I'll still do a contest a little bit, but we'll see. I feel like this channel, I feel like if I could get to cyan or blue, I should be fine for all interviews. Like, if you're able to do this problem, kudos to you, because this is really hard because it's a lot about thinking and game theory, and it's not like, this isn't like regular math. Like, this is like Math Olympiad, but the type of math this is like game theory. But yeah, hope you guys enjoyed this video. Rate, comment, subscribe.